Hello everyone, in this video we are going to talk about cyclic linked list. This video is a continuation of linked list series. If you have missed it, I'll tag in the I button, kindly watch. Previously on DSA we saw the two types of linked list, singly and doubly linked list. They have a node which have two partitions, one will be element and the other will be targeting the next node. We have also discussed about the pros and cons on singly and doubly linked list. Think what happens if you need an iterative list. As an example, you can take repeated music playlist. Now let us see about the cyclic nodes. The cyclic nodes also similar to linked list nodes. They also have two partitions, one will be element and another will be the address of the next node. The cyclic linked list also follows the same procedure of the linked list structure, but the head and tail relationship make them to be feeling unique and adaptive to the linked. These cyclic singly linked lists are adapted version from singly linked list. They have an iterative manner to be linked with the head and tail in a forward traversal. These linked lists are evolved from the existing linked list structure and have few improvements depending on the application needs, and kindly read the pros and cons displayed on the screen. Next, let us see about circular doubly linked list. These are another type of variation where the last node in the list is being connected to the points back to the first node, forming a circular structure. Here, each node has a reference to both previous and the next node as doubly linked list. Now let's get started with the coding part. In today's video, we will be also seeing about the insertion, deletion and searching techniques in linked list. On our previous video, we saw how to implement doubly linked list. In this video, let us see how to implement single and double cyclic linked list. As usual, let us try to do this code in the same file by renaming the original file name to singly cyclic linked list. In my previous video, I have explained this. Naming the files won't affect the original code. So whatever the name we need, we can assume. I will be assuming it as singly cyclic linked list. Now let me start the code with starting class, private static class I will be creating for the node. We already saw the theory, how nodes will be acting and what are the uses of nodes and what role it plays in the linked list. As same, we need to create the node. There will be no changes in node creation process in any type of linked list. On our next step, we need to create the driver program and populate the nodes with random values 1, 2, 3, 4, 5, creating an instance for the node and populating with 1, 2, 3, 4 and 5. Now the data nodes is been populated. Now we need to create the traversal path. As we are using cyclic singly linked list, it's a forward traversal. So head will be connected to the second element and the second element is connected to third element. It goes on. Third will be connected to fourth and fourth will be connected to fifth. And as it is a cyclic linked list, we need to connect the fifth element to the head element. The last element, tail element, should be connected towards the head. The path we create tail to head is the main difference from the singly linked list as comparing to cyclic singly linked list. Now let us start the code with traversing system out. As I am setting up the current value as head, in forward traversal the elements will be printed from head to tail and it must go through the cyclic chain from tail to head and repeat the process. And another difference here I will be using is maximum iters and iterations, because the cyclic linked list will be running through a loop. If the loop is not reached null point, the loop will be continuing infinity times. So I am using here max iter and iter. In a loop, I am using a condition. The iteration level reaches the maximum iter, then the loop must be exited. So this will help us from solving the issue with infinite loops problem. Now initially I will be adding the iter inside the loop. This will act as a counting variable, how many times a loop has been run, and this will find the condition has been reached or not. If the condition has been not reached, we have to handle the error. So we need to add a clause statement. That means if I want to add a if statement, That will provide us the maximum iteration has been reached so that the list of elements can be printed. So I will be adding this statement at the end. Finally, we completed the code. Before running, let us check if everything is right. We have created the class and the node has been created. Now the node elements has been entered 1, 2, 3, 4 and 5, and the traversal path has been set. Now the loop till the maximum items 10 must be printed. The 10 elements should be printed at finally, and let us see what will be in the output. Yes, you can see here 1, 2, 3, 4 and 5, and the 5 will be pointing towards 1, and again 1, 2, 3, 4 and 5. The output is printing. Next, let us see what happens if we change the maximum iteration to 5. As we said maximum iteration to 5, we need to see only the top 5 elements, because it must be only in a single cycle. Let us see what you can see here. 1, 2, 3, 4 and 5 has been printed initially, and let us check with 4. Only till 1, 2, 3 and 4 should be printed. The next iteration should be continued with this print statement, because the cyclic is not completed and the linked list has been ended before the completion of cycle. This is the code for singly cyclic linked list. Next, we will see the doubly cyclic linked list. Now let us change the class name to doubly cyclic linked list and start the code. A single and the doubly cyclic linked list will be most probably same. Just a few areas will be differed, as we saw in the previous video that singly and doubly linked list will be same. Just we will be adding a new variable name called previous. This helps us from two-way traversal in the data node. Now let us create the variable previous for the node and initialize it with null value inside the data node. The process is similar we done in doubly linked list. After assigning the null value, we need to add the traversal path. As we have the forward traversal, we need to, as already we are having the forward traversal path, we need to create a backward traversal path for the nodes. And let us try to print with the current value as head and the current value as tail. Here we have already done for the forward traversal. Now I will do for the backward traversal, naming the current node as current node _1 and iters 1. Just renaming the variables, and I will change the head to tail, because from tail to head it must be printing in a cyclic manner. Fifth element is the tail element, so I will write it as a 5. As same we have been created this. The if statement should be printed if the maximum iters has been not satisfied. I'll change the iters back to 10, and I have missed somewhere. Iters _1 has been missed here. Now let me rename all the variables. This will fix the warning. Actually already it's existing. Now I remove these comment lines. Change the iters back to 10. And the condition checked well. Now the code is ready. Let's run this code. The warnings are fixed now. Let's run. Adding a print statement, we can see. Let me add a print statement and run this code back. Now you can see the two different outputs, forward traversal and the backward traversal. And let me show what happens if this if statement is not there. Why in cyclic linked list it's important. Now the if statement is not there, so we don't know what is happening there. I am removing this condition and now let's run the code. The code is running infinity times, it has no end. So it's a problem. This can be resolved with this if statement. We have saw the doubly linked list. Now let us see the insertion, deletion and searching operation, how it can be done in singly linked list. I will show an example using a singly linked list forward traversal. Anyhow, in my GitHub, I will be uploading the practice questions and the original outputs. You can refer there. Try to solve those questions, you could do the practicals better. Now I will change the name and the class name. The node will be no changes in the node because I explained this in before itself. Whatever we do, the node data won't be changed for the linked list. This class will be existing as same, and we need to create a new insertion function. Before creating insertion function, we need to create an instance for the node class to access the node. Here I am using private and static. I will explain you later why I am using this private statics and about this and why I am using this public. I will create a transverse function. Later I will create the insert function. For traversing, we already saw how to traverse a singly linked list. The same code will be repeated here, but we will be writing it as a function. Here I have used the while loop. If the current node is not null, it will be continue to move to the next node and start printing, as we done similarly in cyclic also. But instead of cyclic, we will be doing in singly linked list. So I have not introduced any iterations. This print statement is to give space. On the next and the previous nodes. Next, let us start with insertion code. For this also we will be creating a function to insert the new data. On previously, for each and every node we will be creating a new class and we will be inserting the data, but for that we will be insertion function has been created. As the same, we will be creating a common class instance which will accept the new data. In this new node, we will be inserting the new data which we receive from the insertion. So we need to declare a variable into data. This data will be collected from the node as the node stores the data in the private static class. The new node data will be inserted. The data which it will be collected from the user, or else we can be giving it as statically. If the head element is null, means the data gets entered as the element head. If the data head is not null, then we must be moving to the next data node and we will be inserting that new data. This is the logic we will be using here. to insert the new data. The current data will be stored as the new next data. So the new element will be added to the existing linked list. In this process, the new nodes will be stored, and we need to also add the deletion. So in the next function, we will be creating a def for deletion function. As similarly we insert the node, we also need to delete the node. So we use the same function and do some modifications. The data must be collected as usual and check if the head is null or not. If the head is null, we will be just returning true. On the next step, we need to find the deletion number. If the head data matches the data of the original number given by the user, then we need to move the head element to the next element so that the previous head element will be removed and the current will be re-initialized as head. That means the next value of the head will be initialized. This previous must be targeting the current value. Until that, it will be null. Next, we want to create a while loop. If the current data is not matched and the current data is not null, we want to assume that previous value as a current value and move forward traversal. This is used to print the statements that what are the elements available inside the nodes. After deleting, this will help us to print the values inside the nodes. This seems to be a bit complicated, but it's very easy. First, we need to see the head value as null or not. Next, if the data matches, we need to convert it to the next value, and the current and the previous node should be altered. If the current value is null, once again we want to check, and we need to print the values inside the data stream. The important step we are doing is assuming the previous value as the next upcoming value of the current value. That means the deleted node will be removed and the next node is assumed as the current node. That's what it's happening here. At last and finally, we need to create the function for searching. That's the next step to do. We want to create a function for searching. In this also we will be using the element, and for each and every function we create, we will be using the public. The public access specifier will be used to call the functions inside the driver program. In searching, we will be using the boolean elements, and the node will be current. Set up as head, the head value will be set up as current value, and we will be traversing into the data stream, and we will find the match for the data given by the user. If the data matches, we will be returning as true, else we will be moving to the next node, and if the data doesn't match, we will be returning false. So the searching will be optimized here. Finally, we completed all the functions: insertion, deletion and searching. The class name and the private class for the instance and the insertion, deletion part, and also completed with the searching part. On our next step, we need to add these functions in the driver program. Now we don't need to add different for each and every element we don't need to create an instance. We are already having a insertion function, so we can directly use that function and we can insert the node. These all are useless now. Now we need to start to create an instance for the main class. That means a singly linked list is our class main class name, and we need to create an instance for that to call these functions. I already explained that public access specifier has been used. So using this instance we can call these public variables. Now I will call the first part to insert the element into the nodes. Here I am facing a problem that I am not able to call the function because this is due to I am calling a private variable. That means a private function cannot be accessed inside the main driver program. So I need to change this access specifiers. So I am removing this code and moving this to the public class function. That means outside this node class. Now you could see the insertion function will be enabled. That means I am not inside the static node class, it's outside, and it still shows the error because the insertion needs a data value to be added. Now we can start the program by adding the values. I will repeat this process. Now we need to print the output. We don't need to again write the complete code. Just by calling the traverse we could see the output. And the search element, I will be initially searching the element for 3. If the element is present inside the nodes, it will be showing as true. So I am using a system out. And next I would like to delete the element 2. So I will be initially deleting element 2 inside the node. After deleting we need to print the values, so I need to initialize the traverse. Now you can see that the output for each and everything has been printed correctly. That's it for this chapter. The analysis metrics and the difference between each and every linked list will be released in shorts. On our next video we will be seeing the next chapter on stacks and queues. Stay tuned for the next video. Like, share and subscribe the channel.